I'm Sabina, and today let's talk about rocket reusability. In 2002, Elon Musk founded a company called SpaceX with the primary goal of getting humans to Mars. Over the course of the last decade, SpaceX has been working on something that has completely changed the face of space travel and exploration, rocket reusability. Falcon 9 was the first truly reusable rocket created by SpaceX. The initial burn carries the Dragon module through the worst mechanical stress of the flight and separates shortly after main engine cutoff. The second stage continues to carry the Dragon module into orbit, while the first stage experiences a boost-back burn to flip the rocket and an entry burn to return it back to Earth. While researching rocket reusability, I started to wonder how the performance of rockets deteriorates over the course of multiple missions. I designed a lab where one model rocket would be launched as many times as possible without detrimental damages and took measurements to track its performance. Using the data collected, I used trigonometry to calculate the deviation from vertical and max height. I graphed the calculated lateral deviation values on a compass graph and max height values as a function of trial number. The ultimate goal was to see lateral deviation increasing and max height decreasing over time. There were multiple issues presented during testing that I had not anticipated, including inclement November weather, which prevented me from doing enough trials to find a definitive trend. There were physical damages that hindered my ability to get accurate data. The purpose of the lab was to see how those damages worsened the performance of the rocket, but some parts were lost. The wind carried the rocket too far from the launch site and it continued to get lost. To prevent this, I cut a hole in the parachute in an attempt to reduce the carrying capacity of the wind, but it did not make much of a difference. Even though this wasn't planned for in the lab, it ultimately demonstrated a valuable lesson about rocket reusability as a whole. SpaceX has been the front runner in the strive for efficiency and rocket reusability, and even they've had multiple launches where the mission was a total failure. Most of these failures were not engineering flaws, but instead small flukes, including unpredictable external factors that triggered a chain reaction of issues. SpaceX's success is attributed to their failures. The solutions they came up with not only solve the problems at hand, but came together to create a spacecraft unimaginable until now. Even with these incredible new pieces of technology, rocket reusability is nowhere near its peak level of efficiency. There are many improvements that still need to be made before we can even dream of inhabiting another planet, primarily the cost of space travel. Overall goal for SpaceX is to colonize Mars, starting from the ground up with trial and error. The solutions to failures they came up with are what is going to make Elon Musk's dream a reality. Elon Musk has estimated the advancements in rocket reusability have already contributed to a 30% price decrease, and it believes that number will decrease to 50% in the coming years. Reaching this point of peak efficiency is vital to the success of the Mars mission. In the end, this case study was not exactly what I anticipated, but it provided a more realistic view of the early stages of rocket reusability and how important the failures actually are. Even though my model rockets aren't heading to Mars, I can use the issues in this experimental design to improve them and maybe run trials in a less windy season.